Hello everyone, I'm going to repair a laptop charger. So if you have studied electronics, if you know about electrics, so this video is about learning how to repair a laptop charger. So let's go and repair one. Thank you guys. Okay, so this is the laptop charger. This is a laptop charger that is not working at the moment. It's not charging my laptop. So I want to show you guys something. So just at the back of the charger, if you can find out the output voltage, it's a DC output voltage. So let's find that just right here. It says output, and it says here 19. And then it's another, I can't see properly, so I have to bring it out and just read it first myself. Maybe I put the lights on. 9 output, 19.5 DC voltage, 2.3 1 ampere, 45 watts. Okay, so I've read it. So if you guys can see it, here is the output. So it's a 19.5 voltage. So it is a DC voltage. The symbol for the DC voltage, it's a straight line, so that's what it's showing. That's a DC voltage, and 2.3 ampere. I can't see it myself, sorry, even though I'm wearing glasses, but it's just so hard. 45.5 or 45 watts. Anyway, you guys probably seen it better than me. So it's 45 watts, 2.3, 31 ampere, 19.3 voltage DC. So I can see it from here, from distance. Okay, so just to get that in mind, we need that 19.5 DC voltage. So 19 is our DC voltage. So what that means is we need to have 19 DC voltage right up here to charge our laptop. Or any charger, mobile charger, any laptop charger, any other electrical device charger. So whatever says at the back of the adapter, on the output, and that should be the output here. So when it says input there, input is here. This is the input. So it says here the input is, it says here input 100 to 240 voltage. So if I can bring it to the camera. So input is somewhere around here. There. So 100 to 240 voltage. and that's a IC voltage, the symbol for IC, and the other numbers which I can't see it from here. So, but we don't need the IC voltage, only if we measure this bit here. So the IC voltage is from the plug to here, and also some of the part of the adapter, and then I'll show you guys from which part it changes to DC voltage. So let's measure the DC voltage. So we do not need the IC voltage at the moment. So we need the DC voltage. We need to check here whether our charges. So if you guys want to test the charger whether it's working or not, you need to test it like this. I'm going to show you. So plug this on the power. So we got light on the charger for mobile. So it's green light. Okay, so the way to check, so you need a multimeter. So my multimeter is a digital one, so so we're measuring DC voltage, so you gotta put it on DC, and so I want to make sure that you guys can see it, so remove these things. Okay, so the way to test it is hold the plug, which is the COM, outside of the charger like this, and the red probe from the multimeter, you put it inside. So you hold it like this, the outside, and you put that inside. So we should get 19.5 DC voltage. So we do not get that, so it's only like 0.0220 or 19. It goes lower, 17, 16, 15, so it's dropping. So I don't know if I can bring it closer. So it's just show you guys from close. If I can get this here. Anyway, the voltage has dropped. It's up to 0.005. So there's no DC voltage. So you see, we should get 19.5 DC voltage, or 19 point something. But we do not have that. So definitely our charger is not working. So let's unplug it. Always unplug when you want to work on the electric devices. Always unplug first, and when you're ready, then you plug it. When you're ready to do other stuff. Okay, so I'm gonna unplug here. So I'm gonna leave it there for a while. And this is our other bits of the charger. So these chargers, they're not easy to sort of because they don't have any bolts mounted on the adapter. So sometimes it comes, you know, what I did with the screwdriver, I just punched it in, and that's what I got. I mean, you know, sometimes you can get a good job out of it, but as my mine one is not really good one. So you gotta sort of open it up with screwdriver and kind of break it basically. So you break the two, and basically then you just left, and these things, they're just for protections, and also this one. So we leave it there. So this is the inside of our charge laptop, my laptop charger. So so what I was saying before is the IC voltage. So here we get the IC voltage, and then so what we got, what sort of components we have inside. So you have an inductor here. For inductors, they change the movement of the electrons from IC to DC. So that's what that does. And then we have like a different capacitor here. And then we got a large capacitor, electrolytic capacitor here. So we would have DC voltage on this capacitor. So we're going to test this capacitor here. Because we only got like 0.005 voltage over here, that goes to the wire. So let's test here in the middle one, the large capacitor, and we see if we got DC voltage here, because what it does at the back of the AC voltage, it was saying 100 to 240 IC voltage, which means the IC voltage would be here, around here, and that would be starting from 240, because the house voltage is 240. So when I'm plugging this one in over here, we would have a 240 DC voltage. So if you guys want to see it, I can show you what I mean, and also that testing our wire, our IC wire, that this wire here. So you can just put your probes in. It doesn't matter like which one is positive and negative, that doesn't matter. And then you can just read the DC IC voltage, and also you can test only the people that they're a little bit of knowledge of electricity, or technicians. So if you've studied electronics, then you can do these sort of things. Otherwise, it's very dangerous. Do not touch it, because you don't want to hurt yourself. Okay, so we're gonna plug this one in. It's our IC voltage. So I'm going to test it for you guys. So this wire. Sorry guys, the reason it wasn't reading, because my multimeter is set on DC voltage. So if you have it on DC voltage, and if you're measuring IC voltages, it will not read the IC voltages. So you need to put it on the correct setting for the multimeter IC voltage. So now, as we plug it in, and it's gonna read 240 IC voltage. So you can change the probes, because I've got them on two. You can put on the negative and the ground or the positive, either way, it will read you the voltage, 240 voltage AC. So that's how you test a wire, but just be in mind it's very dangerous, so you have to be very careful. So now that we've tested our wires working and it's all good. So we had IC voltage was coming in, it's all good. So now let's get the AC voltage. So we put the probes on the DC voltage. So we measure this large capacitor. So we put the black one on the negative and the red one on the positive. So the measurement is 337 DC voltage. So that's what. When it goes read, that means it shows its danger. It means we have electricity, high voltage on the multimeter. So that's why it goes red. Because my hand is moving. So we got 330 DC, 331, 32, 33, 34, 35. Anyway, so our DC voltage is good. So we have half of our board is working. So the IC voltage is coming in, 240 IC voltage is coming in here, and then it's going through this inductor and it's going through those capacitors, and then it's coming to this large capacitor. That's the maximum DC voltage, 334. So the next component on the board is that this is small capacitor here. So we need to get a measurement of that. We need to measure that. If that's, we have to test the voltage on that and see if our capacitor is all good there. So see, I'm always have to be careful so you don't get shocked. Okay, so our probe is on the multimeter is on the DC voltage. So now we have to put measuring the small capacitor. So I'm not going to move around the thing because I don't want it to anything happens. So there's our positive and this is our negative. So we get the measurement. So we got 6.42 DC voltage on that little small capacitor. So that capacitor is also working. So that's good. Okay. So moving forward, so we have this inductor, large inductor. So inductors are like it's inside. It's like a round sort of plastic, or could be metal, could be anything. And then the copper wire is like that, but it's copper. It's wrapped around it, round. and that's what the inductors, they change the movement of the voltages, and also they smoothen the voltages. They can use them for a lot of stuff, like a lot of sort of ways that they want to change they can also smooth the electrons moving inside the wire, and so that's why they have them there. Perhaps maybe because they have DC voltage and they want to keep that DC voltage much better, smoother way, so they have these big inductors there. And the reason they've covered it with the yellow tape is because the inductors, so when they have the copper wire around something, plastic or whatever, so once it's connected to the electricity, the copper wire is kind of, it builds up a magnetic field. Like if you touch close to the wire, once it's connected, you can get shocked, even though you haven't touched your hands, but you get the shock, because the wave of the magnetic electrons, it goes up and it stays up, and it's sort of, once it kind of, the electrons builds up all around in a circle. It builds up above the wire. So that's why they've put the tape, so it keeps the electron inside that inductor, so it doesn't. So when you touch this, it's safe, so it doesn't. You don't get, and also it doesn't damage any other components, or like this one could get melted because the electrons is obviously hot. It gets hot and it will damage everything. So that's why. So the tape is for safety, so it doesn't allow the electrons to escape outside. Okay, so these inductors, they don't get damaged easily, so we don't need to worry about it. These capacitors, they get damaged quite often. They're the main source of our board elements that easily gets damaged, and the rest of the stuff, it's all good. We have I can't see whether it's a 2-leg or 3-leg it's a 3-leg. It's a 3-leg MOSFET. We have a MOSFET here. It's a 3-leg MOSFET, and sometimes that MOSFET can go wrong. But always test the capacitors first, the voltage for the capacitors, because capacitors needs to have voltages stored in them when they're connected with the power, and they have to have the right voltages. They cannot have the wrong voltages, and they have to have like stable voltages. They cannot have like voltages dropping or going up, so they have to have a stable voltage, and they have to have a correct voltage. So this capacitor here is a little bit large capacitor, so I'm going to measure that one. So this is our last capacitor that our 19 DC voltage would be stored on this capacitor, coming from all around here. So the 334 DC voltage on this large capacitor, it goes because we have resistors there, you guys can see it, but I can see it, small resistors and also a diode. The resistors, they drop the voltages, so those resistors, they drop the DC voltages, and as you guys can you saw that the 6 point something voltage was stored here, so our voltage is already dropped from 334 from this capacitor to 6 point something over there. And then we have like a lot of other components here, MOSFET, and a lot of capacitors, small capacitors all around here, and also a lot of resistors that they drop the voltages. So what they've done is actually, by the time the voltage has reached up here, they've accumulated that 19 voltage should be stored on this capacitor, because this is our last element, and 19 voltage should be stored on that capacitor. So that is our last measurement. So we're going to measure the voltage on that capacitor, and we should get a 19 voltage. If we don't, then we'll see. Okay, so multimeters on the DC voltage, so that's correct, so because we're measuring DC voltage. So okay, now before I do the measurement, I have to check where is the negative and positive. The negative is on this side, positive on this side. So yep, so let's do that. Let's measure negative on that side, positive on this side. Okay. So we should get 19 DC voltage, but we only got 0.7, and it's dropping 0.6. It's dropping slowly. The voltage is actually it's actually dropping. So if I just hold this here, if I can, not touching anything else. Anyway, let's see if you guys can. Yeah, you guys can see it from here quite good. I don't need to bring it closer. So it's dropped to zero. You see, the voltage is dropped to zero. It was 0 point something, but it's dropped to zero. So nothing. We got nothing. No voltage on that capacitor. So there we go. So we diagnosed it. We have no voltage on this capacitor. On this capacitor we have no voltage. I can see the capacitor is actually swollen a little bit. Okay, you guys can see. See, a capacitor, the head needs to be flat. Like the large one is flat. It's not. If it's swollen, then that's damage. So I can see it, it's swollen, it's coming up. So when a capacitor gets damaged, it either blows up from the top, or it pops up a little bit, and that also a damage. Or sometimes it doesn't pop up at all, it just stays smooth, soft, flat, and then we know that you have to sort of take the capacitor out and measure it, and if it's not right, then that's damage. So that's when it's kind of flat, if it doesn't show it from the outside, then that's how you have to take it out from the board and test it, and if it doesn't have the right numbers and the microfarad sort of numbers, then it's damaged. So visually that capacitor is damaged, so we're going to take that out and we're going to test it, and we go from there. So let's do that. Okay, so my power is off, but the board still have power. This large capacitor that has voltage, so that's slowly dropping, but if I want to lose the voltage, I have to get something bigger than this one, because it's got 334. It's gonna shock the hell out of me, so I'm just gonna leave it. I'm just not gonna lose the voltage. But if you have a large metal, it's got the handles plastic, or it's covered with something, you can touch both sides and you can withdraw the voltage of that capacitor, of any capacitor. But you have to be careful. Okay, so I'm going to take that capacitor out, and I'm going to test it. I think my gun is hot. It's been there for a while, so it's hot. There we go. It was quite hot. So we're going to now it has risen up a bit, so it's not flat. But so we have 25 voltage and 600 and is it 680 or 6? Yeah, 680 UF microfarad. So we should have close to 680 or 600 at least on this capacitor. So let's measure it. So by measuring a capacitor, my multimeter is gone off. Turn it back on. You need to put it on the capacitor sign. So my multimeter is the capacitor sign is here. There. So you need to put it on the capacitor sign when you're measuring capacitor. And then you put it like this. I'm gonna bring this. Makes it easy for me to that's better. So yeah, it's readable from there. So positive on the positive, negative on the negative. So we measure the capacitor. So how much microfarad we have On the capacitor it says 690 microfarad. So you see, sorry, I just put this up. It's actually make it tight. It's slipping down. Okay. So we get no reading. We get no reading. It goes to U. It changes from NF to UF, but no reading at all. It changes from NF to UF, but there's no reading, no numbers. So that's very damaged capacitor. So this capacitor is a good one. So it's a 25 volt, but it's 470 microfarad, which is a little bit bigger. That's 680. This is 470, 680, 470. So, oh no, that's actually lower. This is higher, 680 and 470. Okay. So we measure this one. This is the correct one. So 470 is our capacitor. Come on. It is point, but nothing, no numbers. Okay, I'm gonna get another capacitor because that's not. So it's 25 voltage. 25 voltage. There's another one. That's 25 and 470. I don't think I have any 680, but I'm gonna have a look anyway. Let's measure this one. Okay, so we have numbers now. It's 505, 500, so just say 500 U microfarad. So close to 470, so we get like 20% up and down, which is normal on the capacitors. So I don't have any 680. I don't have any 680. 68, not 680. 68 is too low. No, that's too high. 1000. Nah. That is 350 voltage too high. 350 now. Okay. So I don't know if the right capacitor, but so we're gonna choose between these two. The one that was reading, I'm gonna put that one. The one that was reading numbers, because that means it's a good capacitor. Which is this one? 500 microfarad. So if I can bring it closer. So 490, 500 microfarad. So 680 we got lower than 190 microfarad lower. So our voltage would be just a little bit high. It will go up from, it will be 19, but it will be point higher, higher than 5 feet, higher than 19.50 it says at the back of here, but it will be a little bit higher, which is not going to change anything. So we're going to replace that one. I'm going to replace it. So I'm gonna put the negative on negative, positive on positive. Okay, so it's going in, we just need to seal it. I'm just going to bend the legs so it doesn't drop out backwards. Okay. Seems like bend it more. Don't want to drop the camera. Sorry guys. So I've bended the legs so it doesn't drop out, so I'm just gonna seal it there. You don't want to damage anything else. That's what the idea is, because it's a lot of other stuff close to the let's bring the camera a little bit closer so you can see. So one side is locked in, the other side needs to be locked. But there's a lot of other stuff close by, which I don't want to interrupt anything that's close by. You don't want to put too much soldier because actually it's got quite a bit of thing there. I need to get some of the stuff out. Need to get some of the stuff. So I put a bit of extra stuff which is touching other components. It's not supposed to. So I just clean it. Yeah, this is good. Clean it with this soldering, desoldering. Okay, so we are good. So let's disconnect it and let's get a measurement. Anyway, before I put it away, let's do a measurement on that capacitor. So negative on this side, positive on this side. So we should get 19 DC voltage at least. Alright, let's connect this. This is too hot, I'm gonna move this so it doesn't touch my wire. Okay. Stay here. Okay, so negative on that side, positive on this side. Let's get measurement. DC. Yes, we're on DC. Okay, like I said, 19.98. So 19 is good. 19 is our voltage, but point we got a little bit extra. 30 points we got extra, but that's okay. We're all good. So let's put it back together. So I think our charge is fixed. We'll do measurement on the end. Okay. There, and this one. Put it just on top like this. This one here. And this one here. Okay. So I'm going to use a sticky tape to hold it. A cloth sticky tape or any sticky tape. So there we go. It's good enough. It's not going to come off. So let's do a measurement here. So before we didn't have any voltage. Now let's see. Let's connect it. Bismillah. And let's get measurement. DC voltage. Right. So we got 19.88 as, so it's fixed 19. We need 19.50, but it's 19.88, which is below 20. It's still good. It's not going to damage the computer, it's going to charge it, because point is still good as long as we get 19. So yeah, thanks guys, thanks for watching, hope you enjoyed it. Don't forget to subscribe.